Hi there, algebra fans. Mrs. Lindsay here to talk to you a little bit today about my friend the wizard named Fraction Begone. He will help you clear out all those nasty fractions that you hate so much in your equations. With a little help and the magic of Desmos. Let's get started, shall we? Fractions are annoying, and the most annoying part about fractions are these denominators, the 2 and the 5. If we could somehow get rid of that 2 and 5, we would be all good with solving this equation. And the way we can do that is using the least common denominator, LCD. And Desmos is going to help us do that. Now, Desmos knows that the LCD is really the least common multiple of the denominators. So I'm going to type into this equation bar LCM parentheses 2, 5. Those are my two denominators that I want to find the least common denominator, or, same thing, least common multiple. And Desmos tells me the least common multiple is 10. You may have already known that, and you might not have needed the Desmos calculator. Well, good for you. But we're going to use 10 in order to multiply through our equation. Back to our original equation here. In order to get rid of the two denominators, the 2 and the 5, I'm going to use the LCM that Desmos told me, or the LCD, and multiply every term by 10. So make sure you write your LCDs in the top, because that is where we want all our terms to be. We want no denominators. So I'm going to hit every single term with a 10. Now, when you do this, we're going to actually multiply each of these denominators to our LCD. And when you multiply fractions, of course, you all know we divide. So 10 divided by 2 is 5. And we get here 5x. 10 divided by 5 is 2. And 2 times 3 is 6. So that's 5x plus 6. And there is no denominator here, so we're just simply going to multiply on the right side of the equal sign, 3 times 10, which is 30. Now it's simply an easy two-step process. We're going to subtract 6 from both sides, leaving us with 5x equals 24, and then divide both sides by 5, giving us a final answer of x equals 24 over 5. And that, of course, once again, is using the LCD of 10. So here is my fractional equation solved for x. But there's more. We can actually check this with Desmos. I'll show you. So what we've done here is we've typed in the solution we got for x into one of the equation bars. And Desmos tells us that x equals 24 over 5 is equivalent to 4.8, which it is. If I type in the left side of the equation, x over 2 plus 3 over 5, I get this red linear equation or line. If I type in the right side, but I have to type it in as an equation, because if I simply type 3, it won't give me a line. So if I type in y equals 3, I see there's an intersection. If I click on the intersection, the x-coordinate of the intersection happens to be 4.8, which is equivalent to our solution, 24 over 5. Either answer will be correct. Now, the other thing that Desmos does that's kind of cool is if I type in 24 over 5 into one of the equation bars, 24 divided by 5. Desmos will give me the decimal equivalent, or if I type in 0.48 or 4.8, there's a little fraction bar here that will tell me it's also 24 over 5. So Desmos can tell you what a decimal is as a fraction, or what a fraction is as a decimal. So the question now is, can we do this with more than 3 terms? Here we have 4 terms, and 3 of them are fractions, with nasty denominators, 3, 2, and 6. First, we need to go to Desmos to see if we can get the LCD of 3, 2, and 6. And here it is. Desmos has found it. The LCM of 3, 2, and 6 is 6, also the LCD. Back to our problem. We're going to hit everything, every single term, with our LCD of 6. So we're going to multiply 6 to the 2/3 x. We're going to multiply 6 to the 2, which of course is not a fraction. I'll write it over 1 and make it a fraction. We're going to multiply 6 to the 3 over 2x, and we're going to multiply 6 to the 1/6. When we do this, of course, we divide the denominator into the numerator. So 6 divided by 3 is 2, and 2 times 2 is 4. This gives me 4x. We don't divide anything because 6 divided by 1 is 6. So this is just 6 times 2 is 12. So 4x minus 12 equals 6 divided by 2 is 3. And 3 times 3 is 9. That gives me 9x. And 6 divided by 6 is 1. 1 times 1 is 1. This gives me a plus 1. All right, we have a little more complicated procedure. We have to get our x's moved to one side. I'll do that by subtracting 4x, because it doesn't really bother me that my x's are on the right side. If I subtract 4x, that means my x's are on the right side, my numbers are on the left side. I'll subtract 1. That gives me negative 13 equals 5x. Now we simply divide both sides by 5. And because equations are symmetrical, I can write negative 13 over 5 equals x, or I can write x equals negative 13 over 5, whichever we prefer. And now we just check in Desmos. So here I've written out in the equation bars in Desmos the solution we got for x. X equals negative 13/5. The left side of the equal sign, 2/3 x minus 2, which gives me a line, this red one. The right side of the equation, 3/2 x plus 1/6, which gives me another line because it does have a variable in it, the x. And at the intersection, we find the x coordinate, negative 2.6. Now, I've taken the opportunity to write negative 2.6 in the last equation bar, and I touched the fraction bar, and it does tell me that negative 2.6 is equivalent to my solution, negative 13/5. So here we know that all is well, and our answer is correct, negative 13/5. So what happens if I run into a situation like this, where I have a fractional equation with variables actually in the denominator? Well, unfortunately, Desmos cannot help you get rid of the variables in the denominator, but it can help you get rid of the number portions of the denominator. So here, my x, Desmos is not going to help me. I can get rid of the 9, and I can get rid of the 3 portion of the 3x. But it's pretty simple to divide out the x if we make part of our LCD x. So if I multiply x to all 3 terms here, I can get x divided by x to cancel out, and I'll be left with 7. I have no x in the denominator of the second term, so I'm just going to leave this exactly the way it is, 2x over 9, and I'll take care of that 9 later. And I do have an x in the third term, but only part of the denominator can be eliminated. So I'm left with negative 5 over 3. Then it's a pretty simple matter to go back to Desmos, or you might just know the LCD of 9 and 3, the LCM, is 9. Desmos would give me that. So now I'm going to multiply every term by 9. Again, 9 times 7, this is 7 over 1, is just 63. The 9s will cancel out here. I'll be left with 2x. And 9 divided by 3 is 3. So I'm left with equals negative 15. Now I have a 2-step problem to solve. Subtract 63 from both sides. I'm left with 2x equals negative 78. And when you divide by 2, you're going to get x is equal to negative 39. And we're going to go right to Desmos and check that to see if it works. Now, these are not linear equations, so I can't type in the left side of the equation and the right side of the equation and find the intersection like I did with the linear equations. But I can replace x with my answer, x equals negative 39, and on the left side, I get a decimal equivalent of 7 over negative 39 plus 2 over 9. And on the right side, I get a decimal equivalent of negative 5 over 3 times negative 39. So you see I've just replaced these x's with negative 39s, just as you would check on a regular calculator. And the added thing here is I can convert both of these answers to fractions and see if the fractional equivalent is correct as well. So I'm just using it strictly as a calculator. And they both turn out to be, if you click on the equation bar all the way to the left, the fraction icon, you're left with 5 over 117 for the left side of the equation and the right side. So indeed, it does balance, and our answer of x equals negative 39 is correct. Hope you learned something. We'll try some of these on our own. I'll see you all tomorrow.